Hello, welcome to Globecom 2020, and my name is Louis. Today I'm going to present our very exciting work, BBB, a lightweight approach to evaluate private blockchains in clouds. And it's a joint work with my students and my friends from Canada. What's a blockchain? I think that by now most of you should know what blockchain is because it's kind of the buzzword for the past 3 to 5 years. And the way to think about it is basically a mechanism to sharing and storing information. And some of the nice property including that it's decentralized, and it's fault tolerant, it's secure, and there are many others properties that people are still like kind of active researching. And there are two main categories of blockchain. One is a public one, meaning that you have no control of the participants, for example, Bitcoin, Ethereum. And then one common usage for enterprise is this private blockchain. For example, Linux Foundation proposed this idea for Hyperledger. It's a very huge ecosystem, and lots of big tech companies are participating. And one of the key relevant technologies is a Hyperledger Fabric. It's one of the very popular private blockchain. And Ethereum also support the private version. But the problem right now is that we have many different progress from many different community. However, one big thing that we are lacking is a universal way of doing benchmarking. And this causes a huge problem because that when different people trying to evaluate blockchain, it's very hard to have a kind of standardized way to compare these systems, and then it's hard to say that which system is more appropriate under the target scenario. And to be honest, there are tons of different benchmarking tools for blockchains, and we have tried several of them. And yeah, for distributed system, there are some generated tools like TEM, Gremlin, Whiteblock, and then Academia. Of course, we love open problems. We also propose tons of them. For example, Blockbench, and also for the Hyperledger, there are many like kind of specifically designed tool to understand the performance for blockchain. However, we tried most of them and we found those are very difficult to use. The first thing is that the assumption is not very clear, and usually this benchmarking is very difficult to use. It requires a deep learning curve in that first we need to have some software engineering idea to learn how to use Dockers, how to solve all those different kind of dependency in able so that we are able to actually run the system and benchmarking it. And I think that for the networking community, what's even more difficult is that these systems, this benchmarking tool, usually they don't consider the underlying network perspective. And then in practice, this is a big deal because in many of the attacks, for example, like Eclipse attack, actually that you need to have an intricate kind of collaboration between that 40 network and then 40 participants in order to kind of break the system. And these observations motivate us to design our own tool, which is called BBB, Boston Blockchain Benchmark. First, we attack the problem that we want it to be very easy to use, even though if you are not familiar with all those fancy deployment tools, you can still use it. And then the second one is that we want to make sure that it provides lots of different configurations so that for your target scenario, you can find a setup that's appropriate for testing. And especially that we focus on the network layer. And then we also make sure that our system is extensible because we implement our architecture, I'll implement the BBB very in a modular way, and then one can easily add a module to design to target a different scenario. And then, yeah, sorry, you can find a report here at GitHub of my students' GitHub. So what's a BBB? The architecture is actually pretty simple. First, the user will need to configure the system, and then once the system is configured using YAML file, and we have our BBB code program, it's based on Python and shell file, it will read a YAML and then launch the mininet, where mininet it's a kind of simulation network that's very easy to use, and then it's a battle test. It's a very widely used emulator in the networking community, and we finding that very useful in our case. And then the mininet will execute the blockchain, and then that's all handled by our BBB code program. So once the blockchain has execute certain amount of time, then our program will collect and analyze the log. Once that it has the statistics, the user can fetch logs. And then as the first step, our system BBB is tailored to Ethereum, but like we are expecting that it's easy to extend to other work. And then the reason that we target Ethereum is that it's one of the most popular kind of cryptocurrency out there. And actually, according to them, it's more than to digital money, more than for cryptocurrency. Actually, it's a service for everyone. And then you can deploy that kind of program on top of smart contract on top of the platform. And then according to this coin market cap company following or analyze this cryptocurrency area, Ethereum is the number two. The market actually is huge, around 52 billion USD dollars, and then it's right behind Bitcoin. And so now let me introduce you some why you should use BBB, because it has a very nice features. The first, as I mentioned, it focuses on the network aspect first, and then it's very easy to use because you can emulate everything, even on 1,000 nodes cluster on your laptop. So it's pretty scalable. And then we also provide a very fine-grained control for the network. For example, we can control the latency for each link, and then the message loss rate, and then the bandwidth, and also control the topology. And then this is something that we have never seen in the previous blockchain benchmarking tool. And it's very easy to use a BBB, so you don't really need to understand the underlying technology. You can just type one command, and then you can install BBB and then figure out all the dependency. And then for our YAML file, it controls the property I mentioned before. Then right now, we already hard-coded for you. You can choose the different topology like single switch, linear tree, and fat tree. And you can control the property of a network link. And then if you want, you can make this as a heterogeneous kind of setup, so that each emulated machine inside the mininet can have a CPU limit. And then YAML file is very easy to read because it's human being friendly. So like you control network, you can choose like what topology you want, and then you can control the link, and then you can control the node, and then yeah. Actually, that's all you need in order to run your own benchmarking on understanding the performance of Ethereum. And what do we mean by configurability is that if you are more advanced, actually you can create your own customized networking topology, and then you can play with a miner configuration, how many miners you want, and then control how many threads can each miner support it. And then just one command, you can invoke we'll launch the main program, and then the main program will read a specific configuration, and then once a certain thing is achieved, it can like terminate miner and close up everything for you, and then generate the stats. So as a user, it's a very friendly to use. So now we present some of the preliminary evaluations. However, I really encourage you to go to our GitHub and then download it and try it yourself. And right now, what we test, or the only thing we support right now is Ethereum. In particular, is the version based on the Go language. And we started is a proof of work algorithm. And most of our evaluation is on a single machine, which is a 16 virtual CPUs and then 104 gigabyte memory, and it's running on Ubuntu. And you can find other like full evaluation in the paper. And then the first one is we want to understand that the latency in like generating a block and then the relationship between link latency. So as you can see here, the median average, they are very close. So that and it's like kind of it seems that the link latency is not a factor. So from that aspect, it's very good. But if you care about the 95 percentile of latency, then not surprisingly, increasing the link latency actually increase the jerf latency. Okay, so that tells you about like something that what the expected or that what's the appropriate guarantees on the network that you want to have in order to ensure smooth performance in Ethereum. Yeah. And then we also test about heterogeneous machines. So let's suppose that different machines or different miner has a different computation power. So overall, everyone is 100%. And then 3 of the machine, they are more powerful. And then 2 of the machine, they are not very powerful. They only have a 10% of like total computation power. And then in this case, not surprisingly, the host 1 and host 2, they have a very low throughput. But like very surprising thing is that host 4, even though it has a higher computation power than others, but the throughput is still pretty low. And then that's something that we don't know, but like that's the power of our benchmarking tool. It tells you that under different scenario, then what might go wrong, and then we hope that by kind of observing this kind of insight will create a positive feedback loop so that the blockchain researcher can look into it and try to figure out what goes wrong, or that maybe that's by design, but that's something good thing, some good observation to know in terms of end users. And then we also want to make sure that it's a scalable as long as your machine is large enough. So like we increase our machine size to 96 virtual CPU and then larger giga by memory. And then in this case, we can actually simulate 30 miners with, and then we also test like 500 millisecond artificial latency per link. And then this is some number we got. And then if you remember actually that it's very similar to what we saw before with like 4 or 5 miners. And so this show you that the Go Ethereum actually has a very stable performance. And then that's something good to know. And yeah, so that basically I introduce you the tool BBB and then like some key properties and show you some simulation. And then it's still work in progress because we want to add more stuff to it, especially we want to include other private blockchains. And then right now we assume that all the miners, they are behaving correctly, but now we also have a way to inject failures, and then that's some other features we want to add. And then right now the network, we only have like this a probabilistic loss rate, but now we hope to add like more even fancier failure. For example, like sometimes down, sometimes up, and then there's also other interference, and then that's also something we can do. So it's a very exciting work, and then hope you will use it and enjoy it. So that's all. And then if you have any questions, feel free to let me know. And then here's my email. Thank you.